dear students and the participants of the course on railway engineering. In this lecture, we are going to continue with the rail control systems. In the train control systems, we have already talked about the various approaches which can be used for the control of the trains on the tracks. Then the related definitions were discussed, and then finally in the previous lecture we talked about the absolute block system. Now in today's lecture we are going to take up a number of aspects, starting with the different train control systems like automatic block system, centralized train control system, automatic train control, then absolute permissive block systems or the moving block systems. And after that there are around 4 or 5 methods which comes under the non-block systems. So, we will be taking up those subsequently. Now, let us start with the automatic block control. Now, in the automatic block control, this is being taken as an absolute block control system improvement. In the absolute block control system, we have looked at the use of the block instruments, taking out of a token, giving it to the pilot or the driver of the locomotive as a authority to move into the section, and then once the train has reached the other station, then this authority is being taken and everything is normalized. Now, in this case of an automatic block control system, it avoids the possibility of accidents due to human negligence. In the case of absolute block control system, lot of involvement was there. There were 2 station masters who were talking with each other. There was locomotive pilot who has been given an authority in terms of a token. So, many such things were happening, and then the cables were also involved in it. So, here this is an improved version where this type of a possibility has been reduced. Now, there may be several block sections between the stations, and one block is of about 5 kilometers to 7 kilometers in length. Now, signals protecting the entry to these sections, they are controlled entirely by the movements of the trains on the stations as detected by the track circuits. So, we have discussed train detection systems where we talked about the track circuits, we talked about the track counters, axle counters. So, those are the things which are going to be utilized here, and they will help in automatically turning the signals on and off with respect to the movement of the train. Now, as soon as the train enters a block, the electric current puts the signal at danger position. That means now no more trains can move into this particular section because there is already one train travelling in the section. And this danger section position will remain there until the train has moved ahead by an adequate distance. Now, again you have to go back and memorize that we talked about the movement on a track, and then there are signals being provided, and the sections have been defined with respect to the location of the signals, but beyond that signal there is some adequate distance which we have discussed. So, this adequate distance, like we talked about as a block overlap, and this block overlap was 180 meters. So, that is what it is talking. So, unless the train has moved beyond by an adequate distance, then only this danger position of the signal will be taken off. Now, the movement of train is controlled by the stop signals which are operated automatically by the passage of the train past the signal. So, that means now this detection is going on as soon as the train is approaching or as soon as it just moves ahead of the signal, that is being detected, and on the basis of that detection, if initially it was showing red color because the train was in location 1, now when it comes to location 2, this will convert to yellow color or green color depending on at what type of an aspect system is being used here. No automatic signal assumes off unless the line is clear not only to the stop signal ahead, but also up to an adequate distance beyond it. That means now this train, when it will start moving and it will come here, then only the change in the color or in the indication will appear. The link is track circuited throughout its length, and it is divided into a series of automatic signaling sections or blocks, each of which is governed by an automatic stop signal. So, as you can see in the diagram, there are different sections being shown, say section 1, section 2, section 3, or say here section 4 can be there, or section 5 can also be there, and so on, depending on the length of the track or the route. So, we are starting with the station section here, from where the train is going to move into the route. So, there are different signals being provided. So, these are the locations of the signals A, B, C, D. With respect to these signals, now the block sections are being decided. So, we have block section being shown as 2, 3, 4 or 5. So, at all of these locations, the track circuiting is being done. And with the help of that track circuiting, if you remember when we were talking these type of aspects previously, when track circuits were discussed, we said that there is an automatic system also which is available, which by itself identifies the physical position of those track circuits, and instead of using the insulated joints so as to show the termination of the track circuit at a particular point. So, on the basis of that, these sections are being defined. Now, when the train is going to move in these particular sections, the automatic stop signals which are provided as A, B, C and D, they are going to function by themselves because they are being connected to those circuits. So, the 3 color aspect signals are used. All the signals are kept in the normal condition, that is green. That means the authority to move into the section is already given. So, when the train is somewhere here, then all of these, they are being put to the green condition. So, that is the normal condition which is generally used when we are talking about the multi-aspect color signals. Now, before the train enters the station section into the block section AB. So, here this is the block section AB. So, if the train enters here, before that the signal at the start of the block section will be green. So, because as I already said that all of these signals we are in advanced condition, they are all being set to green unless and until there is some obstruction, there is something due to which it has to be either yellow or red. Now, as the train enters the block section, so here we are talking about the section between A and B, the signals get actuated and the green light at A disappears and changes to red. So, now as soon as the train enters here, it is going into this section. So, now this green will become red and rest of those signals, they will remain the green. Now, it prohibits the entry of another train in the section AB. So, no other train can come in this section AB because now it is showing red. Therefore, any train which is coming from the back side has to stop at the stop signal. Now, when the train enters the block section BC, that means now it is going ahead. So, it is coming into the BC section. So, the train has come here. As I said, all of these are already green in front. So, as soon as it comes into this BC, now this which was green will convert to red. So, the signal at B becomes red, and at the same time the signal at A turns to yellow light. So, here this was initially red because the train was moving in this particular area, but now the train has moved ahead. So, from red now it becomes yellow. So, there is a change. It has given a caution now. It indicates that no train can now enter the block section BC because the train is already moving in that particular section, but a train can enter block section AB with cautious speed. It is a single yellow color which is being shown. It means now you can come here, but with a reduction in the speed. Now, further, when the train enters the block section CD, now we are moving further ahead. So, we are coming at this location CD. So, what will happen? The green light at C will turn to red. So, this green light at C will change to red. The red light at B, it will turn to yellow. So, now this red light at B which was there, it will become yellow, and the yellow light at A will turn to green. So, this yellow light now is going to become green. It means now the authority is being given to move into the section AB. The authority is given to move in the section BC, but with the cautious speed, and no train can come into the section CD. So, it means the train can enter section AB with the full speed, section BB with cautious speed, but no train can enter the section CD. So, that is what I already defined. Now, it indicates that a distance of two block sections is maintained between the two trains when they are moving with full speed. So, that is the distance which it is going to maintain. So, now it is green. So, train can come in this section and another train is already here. So, these two section gap is there between the running of the two trains. So, that is a space gap which is being created, and that was the one of the approach which we have discussed at the very starting. So, what are the advantage of this system? The human error is eliminated. There is a greater safety and efficiency on the basis of this automatic turning of the signals as green, yellow or red. The loco driver, they will be taking a decision to move into those particular sections with either the permissible speeds or the reduction speeds or the restricted speeds. And there is a less number of people who are required, and because of that less number of people, the chances of the error are also reducing. There is no requirement of the block instruments, and to function the block instruments, get that key out giving the authority. So, those type of requirements are not there in this case. There is a less operating cost and the capital cost. It helps in increasing the traffic density on a road, because now more trains can move at a certain distance behind each other, and still the safety is being maintained. So, more efficiency comes into the system, and that brings in the better traffic density. Less number of locomotives and carriages are required in this particular case, because not much of the shunting operations they are going to be required. So, here the overall system has been shown again. Now, let us look at this one. There is a block being provided here. There are stop signals are being provided at the ends of the block sections, and as I said, all of these stop signals, they are going to show the green color. So, all these are in green color. There is a train which is approaching the first block. So, with respect to the signal, then there is a signal overlap also being shown here, that is a distance up to which the train has to be in a standstill position or a cautious position unless the other signal is changing. Now, as soon as this train enters the first block, so it comes to this particular location. Now, when it comes here, the signal at the back, it is going to turn to red. So, it was green, it has become red, and then still all are green. So, it means this train can continue to moving in the forward direction with the permissible speed. Now, on the basis of this authority which is being given automatically, that this train now moves to the next block, and as soon as it comes into the next block, then the green color signal which was there becomes red here. So, no train can move into this block, but the previous one which was red in color converts into yellow. So, it is giving a caution, and rest in the front side or an advanced side, they are already green color signals. So, that means this train keeps continuously moving, and now it comes into the third block section, and as soon as it comes into the third block section, the entry point stop signal, it turns into red. The previous stop signal, it turns into yellow as compared to the red which was there previously, and the previous signal, that is this one, turns to double yellow. So, when it turns to double yellow, that means a distant signal is there. So, there is a cautious condition, more restricted, you can move in, but then you be ready to stop if the other signal gives you that indication. So, this is how the 4 aspect color coding system is working here. And finally, when the train moves further ahead, it is going beyond this signal overlap, then this is converting into red, whereas the previous one which was red becomes yellow, the yellow becomes double yellow, and the double yellow now turns into green. So, it means now this is 1 block, this is 2 block, and this is 3 block. So, that is the gap which is now available. The train could have come here at this point because there is a double yellow color. So, it is now going to move at a permissible speed. So, we are maintaining the 2 block systems in this case. Now, the another system is a centralized train control system. Now, in the case of centralized train control systems, all operations of the points and signals at various stations on a section, they are being controlled from a centralized location, single location in this particular system, and that is why the name is centralized train control. So, everything is being controlled from one location. It gives the control over all the points and signal indications into the hand of a one single official. The official having control over all the traffic movements on the section is given a designation as dispatcher. So, this person has the authority to dispatch the trains in different blocks or different sections by setting the system while sitting in that room. Now, this is a progressive advancement of the train control systems or whatever techniques which have been used for the controlling of the points and signals together. That means the interlocking of those aspects, so that the trains can safely and efficiently move into the route. So, the advancement, if we look at it from the very starting, we started with the non-interlocked conditions, and there were multiple cables which were used. There is a manpower, they were doing those changes in the levers or the setting of the points or locking of those points. Everything was done by those cable manpower, and they were in contact with the other cabins through telephone systems. But then from those multiple cabin systems, it changed to the single cabin system, and then finally it changed from a single cabin to a remote control of points, and then this has ultimately come to a centralized control. So, very big section is going to be controlled while sitting at one place. Now, what are the features of this particular system? Let us look at it, but rest of the things, as we have discussed previously, they are going to remain the same. And this is one of the latest system which is developed for the controlled movement of the trains. The points and signals, they are operated from one central control room. No signal cabins are required, as we have discussed. It consists of a centralized traffic control panel which displays the illuminated track diagram, and this illumination with respect to the various types of points, various types of crank handles, locations, level crossings, tracks, and the movement on the tracks, that we have discussed when we talked about the interlocking systems also. And it shows the relative positions of the signals, points, and the track circuits together with their reference numbers. So, in the previous lecture also we have looked at the diagrams where all of those locations where such indications were there, they were given certain number. So, they are referred by those numbers. So, arrangement is made to display the stop signals automatically in advance and bring the train to stop to avoid a collision. Okay, so of course, this is the main feature of any of the system which has to be there, because we have to ensure the safety of the movement. Then number of thumb switches are placed below the illuminated track diagram for the control of points. In one of the photograph I have shown you the locations of the switches. So, those location of the switches were there with respect to the control of the points as well as with respect to the control of the signals. So, two sets of those switches were available in that photograph. So, these number of thumb switches which are placed there, now the illuminated diagram is there, then below that those switches are there, those switches are going to control the designated point. And then immediately below these point thumb switches, the signal thumb switches are mounted so as to operate the signals at different locations. So, both of these are going to be provided one after the other, one below the other on that system. The switch is also provided to determine the direction of movement of the train. So, we are going in normal or reverse conditions. So, those settings can also be there. The signals in opposing directions remain in danger. So, any signals which are provided in the opposite direction, they are kept to the red color system. The duty of the drivers is merely to respect the different indications which have been given by the signals. Now, they are not trying to get more information, because all the information is being delivered to them through the signals. So, they simply obey those signals and accordingly take their train at a full permissible speed or a restricted speeds. Then the traffic capacity is increased, thus allowing additional trains to run. There is a reduction in the staff because there is no requirement of the signal cabins. Then dispatcher is free to perform other works as he can arrange the train movements in advance. So, this is also a possibility in this case. You are setting the things. There are methods by which the pre-arrangement is being done, and then as and when it is being required, it can be executed. The points and switches can be operated in few seconds by means of the thumb switches. So, there is no delay. We discussed at one point of a time of delay of 120 seconds, which is a maximum delay which can be there, but here everything is going to happen in few seconds, because there is no communication between the people in terms of talking to them and then assigning the work, whether the levers have to be set for points, switches, or whether the signals have to be set. So, nothing of that sort of a situation is there. Everything is going to be taken control at one location by the people doing it, and that is why that delay is of very less amount. The system is capable of detecting the defects of the track, and if soon there are defects, so we have again discussed this thing, that if different type of defects are there, then what type of indications can be there in terms of either the steady color indication or the flashing indication, or a combination of steady, flashy, or flashing and flashing indications. They all we have discussed previously. Then loco-pilot is informed of the approaching signals by means of a whistle or a red lamp in the cabin, and this further improves the safety. So, if there is a possibility the loco-pilot is not attentive, is not looking at the signal, in that case these two things will help to become that loco-pilot to be attentive and take control and take the decision as per the signal which is being shown. Then automatic train control. Now, it consists of the electrically circuited track, electrical fittings at the wheel brakes of the locomotives. This helps in stopping the train when the driver fails to obey the signal at danger position, and as and when we are talking about as automatic condition, this is being defined by this letter A, which is written on a white disc. Then it works in different ways, like if we talk about a Japanese system, in that a red light continues to lit and the bell keeps ringing in the locomotive cabin for 5 seconds to warn the driver, and if the driver is not attentive, is not taking care of that emergent condition, then the brakes are going to apply by itself. So, we did talk about this type of a system in terms of an automatic protection with respect to the collision system. So, there was automatic collision device or Kavach system which we have discussed. In the Swiss system, a siren continues to blow for 2 to 3 seconds. If still the driver fails to respond, the brakes applies automatically and bring the train to stop. There, in that case, we have discussed that there can be a service distance or brake distance or emergency brake distance, depending on whether there is a violation with respect to the permissible speed or a violation with respect to the danger. Now, if the signal is clear, the brakes will not apply automatically. So, this ATC consists of two parts: mechanical electrical installations to apply the brakes automatically and warning system which is installed in the locomotive cabin. So, that is what is a part of it. So, here you can see the big networks which are displayed in terms of panels here, and then there are terminals also you can see here. So, that is what we discussed, that when we are having those electronic interlocking systems, they can work with the panels as well as with the control terminals. So, and then they should communicate with each other, that it means that this particular terminal may not be showing the whole of the track, it will be showing the part of the track. As you can see, there is a difference in the display which is being shown on these monitors. So, the people who are sitting here, they are looking at those and then can take a decision, whereas here the overall picture is available to the dispatchers. So, here on this side one diagram is being given, and that is also talking in terms of this ATC, where the permitted speed is there, where the train speed, if it is higher, then the brakes are applied. So, the gradual brakes are getting applied and the train speed is getting low, and if there is an emergency brake system condition will be there, then it can come even to a standstill conditions. Then one another system is an absolute permissive block system. So, what is this? In this particular system, the single line section between the points where the sidings or loops are provided, they must be treated as a single block to prevent two trains from entering at the same time. So, from the word itself, it is like permissive. So, it is trying to give some permissions in certain forms, but like in the case of single line section, now where the points where sidings or loops are provided, on the basis of that we are trying to identify that what particular section can be there in which the train cannot move, otherwise the train can be there. So, it reduces the track utilization in the case of trains following one another in the same direction. So, that is where in this particular system, because it is more permissive, more cautious system is there. So, this traffic density is going to reduce. In these cases where the opposing movements, that is train is coming from the opposite direction, the single line section is treated as a single block, and whereas for following movements that the same direction movement, the single line section is treated as a sequence of the smaller blocks, and this allows many trains to be on a single line at the same time. Now, this is done by having the line side signals at several locations along the single line, which functions as the normal block signals for the following movements. Okay, that means the train which is coming from the backside and is following this train. But for opposing movements, all the signals for the opposing train are turned on, that is stop for the section of the track in front of a train that is already being used on a single line section. This permissive block signal is more often used for freight movements than for passenger trains. Another one is a moving block system. In the moving block system, it is again an advanced system which is associated with the automatic train control. In moving block systems, a train's position and speed, they are communicated to the control equipment, which then computes the appropriate headway to be maintained between the two trains which are coming on the same track, and accordingly it manipulates the signal aspects and the speed controls for the trains on the track. That means now it is trying to look at a real time information, and based on this real time information which is available, it tries to work with this headway, that is what is the distance between the two trains when they are moving on the same track in the same direction. So, this is the headway it is trying to compute on the basis of the speed here, that is maybe V1 or V2. Now, once this headway has been computed and there is a minimum threshold which needs to be maintained, what it does is it tries to change the blocks. So, instead of having a block maybe which is going something like this, now it can convert it into this form. Therefore, the train can very easily move up to this, but then there can be a restriction beyond or a reverse of that. So, the fine control over the speeds and the position of the trains allows a tight highways and correspondingly high utilization of the track. That means now you are trying to bring in the trains a bit closer on the basis of that headway which has to be there at a speed. You are not talking about a fixed block system where the blocks have already been defined in this form, and therefore, if the train is here, then another train can try to move here. But now when you are talking about this headway, there may be a possibility now the blocks may change into this way. So, if the train is here, it means the another train which is coming from the back side may take this position. So, that is a tighter arrangement, and because of this tighter arrangement there can be more trains on the track. Now, let us talk about the non-block train control systems. There are different type of the systems which are being there. One engine only system, following train system, pilot guard system, train staff and ticket system, and the section clear system. We will get some idea about these particular systems because now slowly they have gone out. There may be very few locations where this type of systems are still in use. So, one engine or a train only system is what? There is only one locomotive being worked at a time in a single line section between the two stations, or a single station and a spur section of a track with no station at the other end. So, on this track only one locomotive is taking the train ahead. One of the two stations at either end or the sole station, if there is only one station, another one is a spur section station, that means we are assuming that there is a station there, but it is not that way. So, it is designated the base station for this section. The locomotive may be dispatched light or with a vehicle load in either direction at any time. The driver carries a metal token as an authority to move in that certain sections, and this can also be a wooden baton or a written authority. So, there can be different forms in which this authority can be given to the driver to move on that section. Now, this system is usually employed for short single line spurs or light traffic sections, or not on the through lines where the traffic is continuously moving. In one engine only system, no other engine is allowed in the station limits. That is the only one train which is going to be there. So, that is where it restricts the number of trains which can run in this particular section. Another is the following train system. It is a bus modification of the previous one, where we are talking about time interval. So, it is also known as a time interval system, and this time interval between the two trains which are moving in the same direction on the same track is being kept as 15 minutes. And trains are supposed to move at a speed of 25 kilometers per hour. So, a very low speed is there in this case, and there is one train in each 5 kilometers stretch. That means now we are talking about a section which is being divided into 5 kilometers stretches, and there can be one train in those 5 kilometer stretches. The maximum number of trains simultaneously present in a section is restricted to 4. The loco pilot of the train has to carry a written authorization to move into the section. The system is used when there are emergencies, there are failure of block instruments, telephone lines, etc., or in the case of short double line stretches. Then pilot guard system. This pilot guard system is like it is again a sort of an authority system, wherein there is a person who is being designated as a pilot guard. So, that official goes with the train. Here again the time interval and the speeds, they have been capped as 15 minutes and 25 kilometers per hour respectively. The pilot guard of the train carries a written authorization for moving the train into the section. There is only one pilot guard which is allowed to be on duty for a section at any given time. That means there cannot be a possibility that one train is moves with a one pilot guard and now you are given authority to the another pilot guard, because the person is available and asks the person to take a train in the section. So that one person will take the train in that section and has to similarly return back. So rarely the loco pilot or the guard of the train may carry the ticket. In case two or more trains are to leave together from one station, the pilot guard has to travel on the last train. So that tells that yes, now anything ahead is okay, it can move. It is used when it has been agreed upon earlier that the trains will be dispatched in a specific direction using this system, but the precise times are not known in advance, or the communication cannot be established with the destination station immediately prior to sending the train out. In those particular cases, this pilot guard or authority or an official moves with the train. Then train staff and ticket system. So here this staff is not basically a person, it is a device which is being given. So this train staff, say it is a sort of a wooden or a ticket which is used, and the trains may only be dispatched from the station which has physical possession of this train staff. So this system is used when it is necessary to send trains in both directions between the two stations on a single line. The trains are dispatched in the similar manner as we have talked in the case of a train following system. Then train staff replaces the pilot guard physical presence on the board. So the person need not to travel. So there is no requirement of that manpower in this particular case. There is only one train staff for one section. Once the train staff is handed over at the destination station or the end of the section. So end of the section means the two trains are moving here. Now when the train comes at this point, this is the end of the section. So the staff will be given to this train. So this train will move ahead here. So then only the trains can be dispatched in the other direction. Once the train staff acts as a guarantee, and the trains are not simultaneously dispatched in the opposite directions. Then last is the section clear system. In the section clear system, the permission to approach a station is given to a train only when the line is known to be clear up to the first stop signal of the station, and that has to be verified manually. When we say verified manually, it means the station masters, they will be talking to each other to ascertain that up to what particular level the line is clear. The driver is given again a written authority to move into the section with the train. So with this we close our discussion now. So what we discussed were the automatic block systems and the centralized train control systems, and then we have also looked at some of the modifications in that in terms of the automatic train controls of absolute permissive block system, and the latest like the moving block system, which increases the traffic density or allows the trains to move on a track in a more tighter conditions. And then we have looked at 5 of the methods which have been in use in terms of a non-block sections and the train movement on those particular sections. So with this we are closing it now. Thank you. We will be meeting in the next lecture.